Welcome to the SIMATIC S7200 video tutorial for point-to-point communication. Using the function blocks network read, net R, and network write, net W, up to 16 bytes of data can be exchanged between S7200 PLCs via the Profibus cable. The respective communication partner is identified by the address. Using the netR function enables reading a data area from a remote PLC and storing it in a selected data area of the local PLC. Using the netW function enables writing a data area from the local PLC into a selected data area of a remote PLC. This enables communicating with up to 24 PLCs per port via the instruction wizard for netR, netW. As a task, a running light via 3 PLCs shall be configured in Step 7 microwin. The running light concerns the respective output byte 0 of the PLCs and occurs bit by bit, rising from PLC 1 to 3, and falling in the PLC sequence 1, 3, 2. PLC 1 represents the master PLC, which writes to the output bytes of both slave PLCs via the netW function. The netW function is configured using the instruction wizard in Step 7 microwin. The task is divided into the 5 following steps. Step 1. Communication port settings. For identification, unique addresses must first be assigned for the PLCs. The master receives address 2, slave 1 the address 3 and slave 2 the address 4. Address assignment is illustrated with slave 2 as an example. To avoid overlapping addresses, only the PLC to be configured must be connected with the programming device. In Step 7 microwin, you open the view of the system block. Increase the PLC address to 4. Set the baud rate uniform to 187.5 kilobits per second. Load the settings into the PLC. Since for the slaves only the system block contains information, only transmit those to the PLC. Stop the PLC for the transmission. Run mode. Step 2. Generating the program code. The running light is generated in the master PLC. At the beginning, the start bit 2.0 is set for the rising running light. Double word 0 is shifted cycle triggered left, and double word 4 to the right, each by 1 bit. The transfer between rising and falling running light occurs from bit 0.7 to bit 5.7, respectively, from bit 7.0 to start bit 2.0. Output byte 0 of the master results from the logic OR connection of byte 2 with byte 5. Byte 1 or byte 7 results in byte 8, which is written to the output byte of slave 1 via netW, and byte 0 or byte 6 results in byte 9, which is written to the output byte of slave 2 via netW. In network 1 of the operation block of the master project, the start and switching conditions for the rising running light are initialized. The double words VD0 and VD4 are deleted, and bit 2.0 is set. Network 2, the double words are shifted bit by bit. The negative edge of the special marker 0.5 is selected as a seconds clock generator. VD0 is shifted left and VD4 to the right. In network 3, the negative edge of bit V0.7 starts the falling running light with the start bit V5.7. Byte by byte, logic OR connections of rising and falling running lights per PLC occur in network 4. For the master, the result is directly output to QB0, and for the slaves it is intermediately stored in the memory byte 8 or byte 9. Step 3. Configuring the instruction wizard. Open the instruction wizard via Tools. Select the configuration of the netR, netW function. Enter 2 as the number of the operations to be configured. Select the PLC communication port to be used. Configure the first network operation for slave 1. Operation netW. Write 1 byte. Remote PLC S3. Local start byte VB8. Remote start byte QB0. Accordingly, you select remote PLC address 4 and VB9 as local start byte for the network operation with slave 2. Now select an unused V memory area for the network configuration and complete the instruction wizard. Call the subroutine netexec generated by the instruction wizard every scan cycle in network 5. As timeout, you select 2 seconds, assign a free variable address for the cycle bit, and display communication errors at output 1.1. Step 4. Downloading the project into the PLC. Open the system block, and select PLC address 2 for the master, and set the same baud rate as for the slaves. Download the project to the master PLC. Step 5. Function control. With the transition of the master PLC into run mode, the running light is output in the given sequence. If the communication of the master with one of the slaves is interrupted, the running light goes out on the respective slave, and output bit 1. For further information on SIMATIC S7200, please visit us at siemens.com/S7200.